interactive network of knowledge.
Hello friends, in this video we are going to learn about definite integration. Indefinite integration we have discussed in our previous videos, which is an inverse process of differentiation and some methodologies to find the indefinite integration like substitution method, integration by parts, partial fractions and trigonometric functions and some special functions and all. So all these indefinite integration methodologies will be used again here in definite integration with some limits. So what is indefinite integration? Indefinite integration is nothing but finding the area bounded by a curve between the axes. So here you can see a curve y is equal to f of x and up 2 points a and b on the axis. So area bounded by the curve between the points a and b is called definite integral. So how much area is bounded? So how to find this? We have some theorems. Based on the theorems, we'll be finding the area bounded by this curve from the point A to the point B. So what the theorem is? So fundamental theorem of calculus. So here let f of x be a continuous function defined on the closed interval a comma b. So here the interval is closed. This a comma b is closed. So if a comma b is closed, then integral a to b f of x dx will be equal to integral a to b f of x dx will be equal to capital F of x, where capital F of x is nothing but integration of the function f of x and closed interval a to b. So this is equal to f of b minus f of a. So f of b, where b is called upper limit, here b is upper limit and a is lower limit. A is lower limit. So this limit, and in the calculus what we have studied, limits and derivatives, that limit is not same. They both are different. Here this limit is between a and b, how much the function is bounded. That area, finding that area is called definite integrals. So let us see with an example here. 0 to pi by 4 tan square x dx. How to find the area bounded by this tan square x function under 0 to pi by 4. So instead of tan square x, we can write let tan square x is equal to secant square x minus 1. Let tan square x is equal to secant square x minus 1, because we know that tan square x is secant square x minus 1. So in the place of tan square x, 0 to pi by 4, 0 to pi by 4, secant square x minus 1 dx, secant square x minus 1 dx. So when we integrate this, integration of secant square x is tan x, integration of secant square x is tan x. So we'll write tan x and integration of 1 is x. So minus x, and we'll write in closed interval 0 to pi by 4. So according to fundamental theorem of calculus, second fundamental theorem, first we have to substitute the upper limit. So in the place of x, we have to substitute pi by 4. So tan pi by 4 minus pi by 4, and then lower limit minus tan 0 minus 0. So what is tan pi by 4? Tan 45 degrees, which is equal to 1. So 1 minus pi by 4, and here tan 0 is 0. 0 minus 0 is 0 again. So our answer will become 1 minus pi by 4. So value of this tan square x, I mean area bounded by the tan square x, this function, area bounded by this function under the curve 0 to pi by 4 is 1 minus pi by 4. So this is how the definite integral works. Suppose if we are using substitution method what we used in our indefinite integrals, let us see another example. 3 to 8, integral 3 to 8 sine of root x plus 1 by root x plus 1. So in the place of root x plus 1, suppose if I am substituting t, substitution method, here let root x plus 1 is equal to t, assuming root x plus 1 is t, then differentiating this we will get dx by 2 times of root x plus 1 is equal to dt. So our function will become is equal to integral 3 to 8 sine t and dt by 2, sine t into 2 dt, because 1 by root of x plus 1 will become uh, dx by root of x plus 1 will become dt by 2, sorry, dt into 2. So we'll get 2 dt. So this 2 we can take out common, 2 times of integral 3 to 8 sine t dt. What is the integration of sine? It is minus cos. So we'll have here 2 times of minus cos t and 3 to 8. So after integration, again we have to bring back this value of t here. Whatever we have substituted, we have to bring back here. So this will be equal to 2 times of minus of cos, instead of t we have to write x plus 1 under the root and 3 to 8. The limits are 3 to 8. Lower limit is 3 and upper limit is 8. So now we have to use the fundamental theorem of calculus. So minus of cos, if you substitute upper limit, root of 8 plus 1, and then minus of minus cos root of 3 plus 1. So which will be equal to 2 times of minus of cos 8 plus 1 is 9. So which will be equal to minus cos 3, minus into minus we can write plus. So 3 plus 1, 4. So under the root 4, which is cos 2. So cos 2. So this can also be written as 2 times of cos 2 minus cos 3. So this is one method of finding the definite integrals with substitution method. There is another method. Suppose when we use substitution here, instead of root x plus 1, we substituted t. So in that case, we can do the same problem in different method. Like suppose the given question is sine root of x plus 1 by root of x plus 1. Then we assume that let root of x plus 1 is equal to t, then dx by 2 times of root x plus 1 is equal to dt. So from this, root of x plus 1 is equal to t. If x is equal to 3, just we will be changing the limits. So if x is equal to 3, then t will become 2. T will be equal to 2. And then if x is equal to 8, t will become 3. So under the root 8 plus 1 is 9. So under the root 9 will become 3. So here we change the limits also. Then our function will become equal to integral 2 to 3, 2 to 3 sine t, sine t sine t to dt. So 2 is constant, we can take out. So integral of sine is cos minus cos. So minus cos t 2 to 3. Then now here no need to substitute again the root of x plus 1 in the place of t, because we change the limits for t. In previous example, the limits, this limits 3 and 8 is for x, but here the limits of x is changed to limits of t. So upper limit is 3 here and lower limit is 2 here. So directly we can substitute here, use here fundamental theorem of calculus. So 2 times of minus cos 3 minus of minus cos 2. So which is equal to 2 times of minus cos 3, and minus into minus is plus. So we can write first 2 times of cos 2 minus cos 3. So this is another method of finding the definite integrals when we use substitution. So when we use substitution, we'll change the limit of the function. So if the limits of the function is given in terms of x, then we'll change the limits of the functions to terms of y. This is how we'll use in substitution method.